19, we want to simplify. So I'm going to factor the top and bottom. 14. Multiplies together give you a negative 14, yet added gives me a negative 5. Looks like a 7 and 2. Looks like an n minus 7 times an n plus 2. Yep, that works. The bottom, looks like just an n factors out. I'm left behind with an n plus 2. Now, n plus 2's can cross out. So this guy simplifies to basically n minus 7 over n. Now we can see n can't be 0. But who did you cross out that it isn't viewable now? If they just say, oh, it's n minus 7 over n, they don't realize that right here, that n could not be a negative 2. So we need to tell them, hey, this simplifies to this as long as n isn't a negative 2. Because if you plug negative 2 into the n there, you're going to get a 0, and you cannot put things in groups of 0. You can't divide by 0. So you must make sure you put that idea that n can't be negative 2, that restriction on it. Next one. Well, I notice the top is a difference of squares. The bottom 30. Ooh, it's a positive 30, yet you got a negative there. That tells me that it's a negative times negative. Looks like an n minus 6, n minus 5. Now, the nice thing is that and that are exactly the same. So this simplifies to an n plus 6 over n minus 5. Let's say n's 100. Would you rather plug 100 in here and here and here? Or just go, oh, it's 100 plus 6 over 100 minus 5. Yeah, 106 over 95 is a lot quicker than plugging in there. Now, the one thing we must realize is when we cross this out in the denominator, we have to make a statement that n can't be a 6. Because right here, 6 minus 6 would create a 0, and 0 times whatever is going to be 0, and you can't have a 0 in the denominator. We must make these state these restrictions. $21. Well, I see it. I'm like, hey, let's factor. Top, well, that's easy as can be. N plus 3, n plus 7. Because 7 times 3 is 21, and 7 plus 3 is the 10. In the bottom of 12, 4 and 3. N plus 4, n plus 3. So just factoring it. I'm like, hey, that and that disappear. So this guy simplifies to an n plus 7 over an n plus 4. What is the restriction, though? Who did you cross out? Who can't n be? Can't be a negative 3. And you wouldn't notice that if you just were looking here. You think, oh, I can plug negative 3 in. But you can't, because if you plug negative 3 into the original equation, that right there is going to become a 0. And you can't have a 0 in the denominator. Well, factor the top. Multiplies 15, adds 8. Looks like a 3 and a 5. The bottom looks like n plus a 5, n minus a 4. Because 5 times 4 is 20, and it's a negative 20, so one of them's negative. And then a positive 5 and negative 4 gives me a positive n. Does anybody go away? Of course they do. What a boring problem if they didn't. N plus 3 over n minus 4. That's a lot simpler to look at than that guy. But what is our restriction? We cross this out, n plus 5. N was not able to be a negative 5. It would have created a 0 there. There we have them.